Welcome to today's explainer, the invisible shield demystifying backflow prevention. Today we're really focusing in on those completely unseen plumbing safeguards that literally protect our daily drinking water. Okay, let's dive into this.
Think about it for a second. What actually keeps dirty water from flowing backward right into your drinking glass? We all just kind of naturally expect our municipal plumbing to act like this highly engineered one-way street, right? You open a tap, clean water flows out, and it never goes back in. But without some very specific advanced safeguards in place, that safe one-way street can easily turn into a pretty dangerous two-way highway just because of everyday vulnerabilities in the system.
So let's establish exactly what's at stake here, because the stakes are incredibly high. We're looking at a truly invisible threat. If water were to travel backward through our pipes, we aren't just talking about a little bit of dirt getting in there. No way. We're talking about drawing in nasty chemicals, raw wastewater, agricultural fertilizers, pesticides, all sorts of highly unsafe substances. And listen, when these systems fail, the danger is absolutely not theoretical. It's a very real, immediate risk for residents, workers, and just everyday people who are suddenly exposed to some pretty severe hazards.
Now, to figure out how we actually stop this from happening, we first have to understand the phenomenon itself. The official industry term for this is backflow. By definition, backflow occurs when the normal direction of water flow is completely reversed. And when this reversal happens, it can potentially draw all of those dangerous pollutants we just talked about right back into a community's or a building's potable drinking water supply. Ultimately, the whole thing comes down to a literal battle of physical forces. And this brilliantly illustrates the physics of that failure. During normal flow, you have this stable pressure from the public water main that just safely pushes clean water out to your home's fixtures. Easy enough. But in a reverse flow scenario, say when the pressure in a building's plumbing suddenly exceeds the main, or the main pressure just drops precipitously, that specific pressure change literally pulls unsafe water backward into the main supply. It acts almost like a vacuum.
So how exactly does that happen in our day-to-day lives? Well, it's basically a chain reaction. Let's walk through it. Step 1. Some everyday condition disrupts the system. Maybe a public water main breaks right down the street, or there's a sudden, massive spike in water demand, or municipal pumps temporarily fail. Then, step 2. That disruption causes a sudden and severe drop in pressure, completely destroying the normal pressure balance in the pipes. And finally, step 3, governed entirely by fluid dynamics, that sudden pressure deficit causes the flow of water to reverse its direction entirely.
Now, the exact physical pathways this contamination takes are known as cross-connections. These are the actual physical junctions between your clean, potable water and a non-potable or unsafe source. If backflow protection is completely absent, or if it happens to fail at these specific junctions, that is exactly what makes the whole situation so hazardous. Without a reliable safeguard, these cross-connections act as direct, wide-open pathways for contamination to just waltz right in. To really ground these technical terms in reality for a second, you really don't need a massive industrial factory to create a dangerous cross-connection. Actually, even a small, everyday connection right outside your house, like your home's garden irrigation line tied into your water system, that can easily become a dangerous pathway. Imagine if a pressure drop occurs while your sprinkler system is sitting in a big puddle of fertilizer-soaked water, and you don't have protection. Well, that contaminated puddle is getting drawn right back into your home's drinking lines.
Let's move to and see how this builds into our engineering solutions. To combat this whole issue, certified plumbing professionals install highly specific mechanical prevention devices. Depending on the site's hazard level and the specific pressure conditions of the plumbing setup, they might use things like check valves, reduced pressure principle or RP assemblies, or these really complex double check systems. Basically, these mechanical safeguards are specifically selected to match the unique risks of the property, physically blocking the water from ever moving backward. But, here's the catch. These mechanical assemblies are incredibly tough, for sure, but they are definitely not invincible. Over time, internal components can and frankly do wear out. Springs lose their tension, and valves might simply fail to seal correctly against that reverse pressure. This is exactly why proper testing and maintenance are absolutely vital. Think about it. A backflow preventer that hasn't been looked at in years might not close when you actually need it most. Regular inspections are just an essential part of making sure the device actually functions exactly as intended. So the crucial point is that this shifts our perspective from a localized, purely mechanical issue to a much more widespread societal one. As industry experts are quick to point out, public water systems serve entire communities, right? And a single, tiny cross-connection can affect multiple households or even businesses if backflow enters that main supply.
Because we all share a public water system, we inherently have a shared public health responsibility. Your unprotected pipes could theoretically contaminate your neighbor's tap water. Because the consequences of that kind of widespread contamination are so incredibly severe, local and state regulations actively step in. The law typically mandates strict backflow prevention for specific types of buildings, just to prevent outbreaks of waterborne illnesses. We're talking about targeting locations with extensive irrigation systems, commercial facilities that use chemicals, large buildings equipped with fire suppression systems, and essentially any site where elevated hazards exist. Ultimately, these laws are designed to limit our collective exposure to harmful substances.
And making sure this whole protective system stays intact, well, that requires an entire chain of accountability. It starts right at the top with the property owners and water customers who are legally responsible. But it also heavily relies on facility managers to handle risk assessments, certified plumbing professionals to perform the correct device selection and proper installation, and of course, the local water utilities to specify the exact requirements. This chain also ensures that scheduled testing is completed on time and that proper documentation and compliance records are rigorously kept up to date.
Which brings us to a final, very provocative thought to end our explainer on today. When was the last time your property's unseen safeguards were checked? Really think about that. The next time you turn on your tap for a simple, refreshing drink of water, take a moment to respect the hidden systems and the incredibly specific engineering working tirelessly behind the scenes to keep you and your entire community safe. Thanks so much for joining me today to explore the surprisingly fascinating mechanics of backflow prevention.